Pre-Cal, Chapter 7.1, Right Triangle Trig. This is mostly a review. Right triangle trig is something you've seen for a while if you remember SOHCAHTOA. SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Now we're just adding in the cosecant, secant, and cotangent, remembering that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So to find the values of 6 trig functions, first you need the Pythagorean theorem, because we only have 2 of the sides. Pythagorean theorem is a squared plus b squared equals c squared. And that only works for a right triangle. A and b are your legs and c is your hypotenuse. So here we have 3 squared plus b squared equals 5 squared. So I have 9 plus b squared equals 25. Subtract your 9 from both sides and you get b squared equals 16. Take the square root. Typically when you solve an equation, you take positive and negative square root, but because we're talking about a length, a distance, it has to be just the positive square root. So our b value is 4. So then to find the values of the 6 trig functions, it has to define an angle. So we're going to define the angle, this one, theta. So we don't know the angle measure, we're just finding the values of the trig functions. So the sine of theta, once you find your angle, it's good to go ahead and label your triangle. Your hypotenuse is always the one across from your right angle. Your opposite is the one that's across from your angle you're talking about. And your adjacent is the one that's next to the angle you're talking about. So sine equals opposite over hypotenuse, so that'll be 4/5. And cosecant is the reciprocal of that. So it would be the hypotenuse over the opposite, or 5/4. Cosine of theta is the adjacent over the hypotenuse, so that would be 3/5. And the secant of theta would be the hypotenuse over the adjacent, or the reciprocal of cosine, 5/3. Tangent of theta is opposite over adjacent, so that's 4/3. And the cotangent of theta is adjacent over the opposite, which is 3/4. A rain gutter is to be constructed of aluminum sheets 12 inches wide. After marking off a length of 4 inches from edge to edge, this length is bent up at an angle theta. So this is our angle theta that we don't know. They're 12 inches wide. Each of these is 4 inches. Okay. This length is bent up at an angle theta. Express the area A of an opening as a function of theta. So the area of a triangle formula is 1/2 A times B, or base times height. So if we look at this triangle though, we want the area of this opening piece. So of all of this, of this triangle, and of this rectangle. Okay. So it had A labeled here. This is our A value, and this is our B value. So to find the area of the triangle, it's 1/2 base times height, or 1/2 A times B. This would be a right angle here. So we know that because the hypotenuse here is 4, the cosine of this angle, theta, is adjacent over hypotenuse. So the cosine of theta is A over 4. And we know that the sine of theta is opposite over hypotenuse, so that would be B over 4. So what we can do is since we have these equations for A and B, we can solve them for A and B and plug them into this formula here. So if we multiply both sides by 4 here, we get A equals 4 times the cosine of my angle theta. And B equals 4 times the sine of my angle theta. That's where we get this formula. The area of my triangle is 1/2 For A, I'm plugging in the 4 cosine, and for B, I'm plugging in 4 sine. So 4 cosine of theta times 4 sine of theta. And when you simplify that, the area of your triangle, 1/2 times 4 is 2, times 4 is 8. So I have 8 cosine of theta, sine of theta. So that's the one for our triangle, for one of our triangles. Because we have 2 triangles, so I need a little more space than I've got there. Because I have 2 triangles, I have to multiply that by 2. So I have 2 times 8 times the cosine of theta times the sine of theta, which is 16 cosine of theta, sine of theta. The area of the rectangle is 4b, because we have 4, or length times height there, so my area for my rectangle is 4 times b. So b is the sine of theta, so what I'm going to do is my area of my rectangle equals 4 times b, which is 4 sine of theta, which is 16 sine of theta. Now to find the area of the whole thing, I add the area of my 2 triangles and the area of my rectangle together. So my area is going to be 16 cosine of theta, sine of theta, plus 16 sine of theta. I can factor this out and make it look a little neater by pulling a 16 sine of theta out. And that's going to equal 16 sine of theta times the cosine of theta when I divide this piece, and then plus 1 right here. Now that I have that equation, so this is express the area as an opening as a function of theta. So now theta is our variable instead of A and B. So that's our equation. And then what we're going to do to find the angle that makes theta the largest, we're going to graph this. When we're graphing this, we're talking about angle measure, so we're going to put it in degrees mode. Your calculator typically resets into radians mode, so it needs to be in degrees mode. I'm going to graph this. 16 sine of theta times the cosine of theta. Oh, I need to open up that part. Plus 1. I'm going to adjust my window here. Look at my graph. Oops, sorry. Okay, so here's my graph. And this is kind of hard to see. It looks linear, but I'm going to adjust my window from my x values 0 to 90. I don't care about negative x values. We're talking about angle measures here. So I'm going to go up to 90 degrees because I know that theta is not going to be 90 degrees because I'm bending it up. If it's at 90 degrees, then it just makes a box. So my window, I'm going from 0 to 90 here. And then y would be what my area is. If it was a box, the area would just be 16. So I'm going to go a little higher than that. The reason that we know that the area would be 16 is if we folded this up, we'd have a 4 by 4. So it'd just be 16. So I'm going to put this at like 25, which is something so I can see the picture. And now you can kind of see its curve, that it's not linear, where it's coming back down. And now my maximum, I'm going to use second trace. Option 4, you can also do this on Desmos to the left of my maximum point. And then I'm just kind of watching my y values to see when it peaks and when it goes back down. Right bound, enter twice. And my maximum is at 60 degrees. And then my area at that point is 20.8 inches squared, roughly. So my maximum is at 60, 20.8. So my angle measure is going to be 60 degrees. That gives me the biggest area for the inside. Complementary angle theorem. Cofunctions of complementary angles are equal. So cofunctions are a little different than what we're used to them being, than our reciprocal functions, okay? Cofunctions are what you would think they would be, the sine and the cosine, the cosecant and the secant, the cotangent and the tangent. So complementary angles, remember that complementary angles are two angles where the sum is 90 degrees, is a right angle. And complementary angles of cofunctions cofunctions of complementary angles are equal. So 30 plus 60 gives me 90, so sine of 30 and cosine of 60 are equal. 40 plus 50 gives me 90, so tangent of 40 and cotangent of 50 are equal. So using the complementary angle theorem here, the sine of 62 is going to equal the cosine of the complementary angle. So that's 90 minus 62, which is 28. Remember that 90 degrees is equivalent to pi over 2. So the tangent of pi over 12 is going to equal the cotangent of pi over 2, or 1/2, minus the pi over 12. Remember to do that in your calculator and get an exact value. You leave the pi out, and then you put it back in when you do it. So we have the cotangent of 5 pi over 12. This one, the sine squared of 40 degrees plus the sine squared of 50 degrees equals, what are we going to do here? So remember the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1. Your thetas have to be equal. So I'm going to take one of these guys and try to rewrite it as sine or as cosine and see if it goes away. So I'm just going to take the second one. So this would be equal to the cosine of 90 minus 50, which is 40. So I have the sine squared of my 40 degrees plus the cosine squared of 40 degrees. That fills out this formula and I get. Solving right triangles. When it says to solve the triangle, that means that you need to find all of the values of the triangle. So when we have right triangles here, remember that the sum of the interior angles of a triangle equal 180 degrees. So we're going to use that in our trig functions to solve this. So we're given here a 40-degree angle and a 2 on the leg. So we need to find beta. Beta is going to be the easiest thing to find because those two together have to equal 90 because we have a 90-degree angle. So I'm saying 90 minus 40, which is 50 degrees. So that's beta. Now I need to find C or A. It doesn't matter which one you want to pick. I'm going to use A first. If I use this angle here that I was given, 40 degrees, A and 2, because I only have the other side of 2, I can label this triangle based on this angle. A is my opposite side and 2 is my adjacent side. So opposite over adjacent is tangent. So I can say the tangent of 40 degrees equals my opposite, which is A, over my adjacent, which is 2. Again, your calculator has to be in degrees mode. So I have A equals 2 times the tangent of 40, and I'll just type that in, 2 tangent of 40. And we're going to round to, let's say, 2 decimal places, and you get 1.68. You could do a trig function again to find C, or you can use the Pythagorean theorem. So remember that A squared plus B squared equals C squared. So 1.68 squared plus 2 squared equals C squared. And I'm just going to plug this into my calculator and take the square root. So you get 6.8224 equals C squared. Take the square root of that and you get C equals 2.61. The next one, I have 2 sides and no angles. So first I'm going to find C because that's going to be the easiest thing to find. I have 3 squared plus 2 squared equals C squared. You get 13 equals C squared. The square root of 13, 3.61. When you're finding an angle, you're going to use the inverse trig function. So you just pick which angle you want to find first. I'm going to find alpha first. And then I have these two sides, my opposite and my adjacent. So I'm going to use the tangent. The tangent of angle alpha equals my opposite, which is 3, over my adjacent, which is 2. To get alpha by itself, I take the inverse tangent of both sides. So I get alpha equals the inverse tangent of 3 over 2. In your calculator, as long as you're still in degrees mode, you'll hit second tangent to get that inverse tangent of 3 over 2. Oh, shoot. And you get 56.3 degrees. And then you can get beta by doing the same thing, or you can say 90 minus the 56.3 and get 33.7 degrees. The surveyor can measure the width of the river by setting up a transit at point C on one side of the river and taking a siding of point A on the other side. After running through an angle of 90 degrees at C, the surveyor walks a distance of 200 meters to point B, so that makes this 200 meters. Using the transit at B, the angle beta is measured and found to be 20 degrees. So that's this angle here is 20 degrees. What is the width of the river rounded to the nearest meter? So we want this value. So if we have this value and we have this angle, angle B here, then I'm going to label my triangle. X would be my opposite. The 200 would be my adjacent, so I'm going to use the tangent. The tangent of 20 degrees is going to equal my opposite, which is X, over my adjacent, which is 200. Multiply both sides by 200 to get X by itself. And in your calculator, 200 times the tangent of 20 degrees gives you 72.8 meters. The next one, a straight trail leads from the Alpine Hotel at an elevation of 8,000 feet to a scenic overlook elevation 11,100 feet. The length of the trail is 14,100 feet. What is the inclination of the trail? So we want to find the angle beta in the figure. So if this is 8,000 feet high and this is 11,100 feet high, then that makes this height 3,100 feet. Okay, so we'll subtract those two heights to find this distance. We know that the length of the trail here is 14,100 feet. So we want to find this angle beta. So I have my opposite here at 3,100 feet from beta, and I have my hypotenuse here at 14,100 feet. So opposite and hypotenuse, I'm going to use the sine. The sine of my angle beta equals the opposite, which is 3,100 feet, over the hypotenuse, which is 14,100 feet. To find beta, I'll take the inverse sine. So the inverse sine of 3,100 over 141, there you go. And I'll just type that in my calculator. Inverse sine 3,100 divided by 14100, and you get 12.7 degrees. Angle of elevation and angle of depression. Your angle of elevation is horizontal, so it's from the horizontal distance to the ground, so the one that's parallel to the ground, and then the angle from your line of sight up to what you're looking at. An angle of depression this is your distance here, what you're looking at, and if you're looking down from that, this will be your angle of depression. So these diagrams can help you with that, and we'll leave that for the next couple. On December 1st, 2001, at Midway Airport in Chicago, a ceilometer with a base of 300 feet was employed to find the height of the cloud cover. If the angle of elevation of the light detector is 75 degrees, what is the height of the cloud cover? So the angle of elevation, that makes this 75 degrees. And the base here was 300 feet. We want to know the height. So we have our opposite and we have our adjacent to this angle theta. So we're going to use the tangent. The tangent of 75 degrees equals our opposite, which is h, over our adjacent, which is 300. Multiply both sides by 300 to get h by itself. Then you get h equals, in your calculator, 300 times the tangent of 75, which is 1,119.6 feet. Adorning the top of the Board of Trade building in Chicago is a statue of Ceres, the Greek goddess of wheat. From street level, 2 observations are taken 400 feet from the center of the building. The angle of elevation to the base of the statue is found to be 45 degrees, and the angle of elevation to the top of the statue is 47.2 degrees. What is the height of the statue? So if I know that this, and this diagram is slightly off, sorry, if that this is 400 feet, and that this is 45, and this is 47.2, I can take the, use the tangent because I have my opposite over here, my adjacent here, of each of these to find the height of the overall, and then the height of just the building, subtract the 2 to find the height of my statue. So to find the height of the whole thing, I'm going to use the angle 47.2. So I have the tangent of 47.2 degrees equals my opposite, which is my height overall, over my adjacent, which is 400. Multiply both sides by 400. 400 times the tangent of 47.2 is 431.96. I'm going to round that to 432. Sorry. And then I'm going to do the same thing to find the height of just the building, except for I'm going to use the angle of 45 degrees. So I have the tangent of 45 degrees equals the opposite over the adjacent. Multiply both sides by 400. And this one, you get the height is 400 times tangent of 45 is 400. So the height of the building is 400 feet. The height of the building and the statue is 432 feet. Subtract those 2 from each other, and you get the statue is 32 feet tall. In operation since 1846, the Gibbs Hill Lighthouse stands 117 feet high on a hill that is 245 feet high. So its beam of light is 362 feet above sea level. The brochure states that the light can be seen on the horizon about 26 miles distant. Verify the accuracy of this statement. So we are given that the radius of the Earth here to get our right triangle, which is what this one is 3,960 miles. And that this one is 362 feet. Sorry, that's a typo. 362 feet. So this hypotenuse here, we need to convert this into miles or feet. So I'm going to convert it into, I'm going to convert the feet into miles. So to convert that, I have 362 feet. I have 1 mile, and 1 mile has 5,280 feet. So I'm going to convert that. 362 divided by 5,280. And I'm going to make that a fraction, 181 over 2640. So now to find this value here, I need to find my arc length, S equals R theta, which would be how distant it is. So this is going to be a distance. They say that the S is 26 miles. So the overall goal here is to find this angle so that I can find the arc length. Remember we had the formula from a previous unit, S equals R theta, but theta had to be in radians. So we need our angle measure here because we have our radius to find our arc length. So if we have this right triangle set up, we can use this side here. The hypotenuse is going to be the 3960 and 181 over 2640 miles, right? And then our adjacent here is the 3,960 miles. So we'll use our cosine of our angle measure theta. Cosine is adjacent, which is 3960, over my opposite, which was the 3960 plus the 181 over 2640. And then I'll take the inverse cosine of that to find my angle theta. So the inverse cosine of 3960 divided by 3960 plus 181 over 2640. And you get 0.33715 degrees. So now I need to convert that to radians so that I can plug it into my arc length formula. So times pi over 180. So divide that by 180. And you get, so multiply that by pi, 0.005884 radians. So now I'm going to plug that into my arc length formula. So S equals my radius, which is 3960 times my angle in radians, 0.005884. So my arc length there is 23.3 miles. So since this arc length is 23.3 miles that you can see it on, you cannot see it 26 miles away. So this is not accurate. Just a few more. We're going to look at some angles, some bearings, and navigation or surveying the direction or bearing from a point to a point P is the acute angle theta between the ray OP and the vertical line through O, the north and south line. So it's the acute angle from there to the north-south line. What is the bearing from O to an object at P4? So if you look at O, and then which is your origin, and object at P4, what we have is how we're going to write this bearing because it's closer to south, right, than north. That means we're going to start south, and then we're 20 degrees to the east from south. So south 20 degrees east is P4. If we were to write another one of those, so let's say we did, we have P1 here is north 30 degrees east, P3 here is north 70 degrees west, because we're mainly north, we're more north than south, but we're also 70 degrees to the west. And then here we have south 50 degrees west. A Boeing 777 aircraft takes off from O'Hare Airport on runway 2 left, which has a bearing of north 20 degrees east. After flying for 1 mile, the pilot of the aircraft requests permission to turn 90 degrees and head towards the northwest. The request is granted. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? So basically we want to find this angle measure and call that and write it as a bearing. So this is 1 mile. Then we turned 90 degrees and went for 2 miles, is what it said. So we can set this up in a couple different ways. I am going to find this whole angle here using, I have my opposite here because this is my right angle, and I have my adjacent here. So I'm going to say the tangent of this angle that I'm going to call theta is equal to my opposite over my adjacent. So I'm going to take the inverse tangent of 2 inverse tangent of 2 gives me 63.4 degrees. So since I know that this whole angle is 63.4 and that this portion of the angle is 20, I can say 63.4 minus 20 to get me that portion, which is 43.4. So then this angle, I'm going to call it x, is 43.4 degrees. So that means my bearing is going to be north because we're headed more north than south, and then 43.4 degrees towards the west.